Uh, Here is again the circuit. I was preparing the SMD chip 7414, and I actually made the entire circuit diagram here plus the buzzers. It must be 5 volts active buzzer here. I'm specifying it. Here is exactly what I use, 100 kilo here, that one, and 1 nanofarad there for the signal. But by looking at the circuit, I managed to observe something very strange, and I tried to correct it, and it didn't work normal. Do you see there is no negative rail for the chip? You see, it's only the positive link there, but the negative is not activated. So the chip is not activated pretty much, but it's still working as it should be. So if I'm connecting the negative rail right now to its pin, do you see how is working? You see? It's trying to do it right, but not really. It's randomly doing it like that. No way. And if I'm removing, the negative link from there, I am getting a slight buzzing, like a light hissing, like a static from the buzzer, but it's not interfering with the other circuit. It's running correctly every time. No problem, absolutely no problem whatsoever. So if it's working, even if it's not absolutely correctly linked, everything, only the positive wire connected to the chip, I say it's a winner. Yeah, I did this experimentally, so I don't know this trick from a book or something like that, or from internet. It's just purely experimentally. That's interesting. That's very interesting. That is working with only a positive rail. And if I'm removing that as well, you can actually hear it a tiny little bit, but it's not having power to power the gates. So at least the positive rail must be connected, but it's still functioning. It's still doing something even without the the positive power rail. I wonder if I'm removing this and I'm putting the negative back to it, what's happening. I bet it will go nuts as well. No, it's not working, but I can hear a slight blip, tiny little bit of blip. You hear it? Very light. Actually, I can hear it without that negative link as well. So it doesn't matter the negative link, only the positive link matters. There it is. I believe why is going nuts here is because this last gate probably is, or the first gate actually is drawing too much current from this through and surging too rapidly to the negative rail, and somehow is getting a feedback or something, and is interfering with the other circuit that is creating the signal. Very interesting. But more than interesting is my result here without the negative rail, without kicking back, Yeah, I believe what is doing, this first one that let me close it a little bit. This first gate that I guess it's the bad boy that is kicking back the signal. When it's coming here, this one is like reverberating the signal and is influencing the circuit here. And when I'm connecting the negative rail to the chip, I believe it is having enough power to create that signal when it's properly linked. The chip itself is properly amplifying the signal, is working correctly like that, properly amplifying the signal, and that's why it's having the power to kick back and to create that noisy back signal probably. But without that negative rail, it must surge through the coil, or through this 100 kilo. But I don't think so. I really don't think so. It is having it is too much current to surge through this very tiny little bit, this very high value resistor when it's kicking back. I mean, so the current must go through the second one, and if the second one is kicking back, is stopping on the output here probably. I'm making a direction from it for the kicking back. It's my interpretation. I don't exactly know what's happening in this black box. Well, that one. I hope they will work exactly. They will have the exact same functionality without this one, without the negative rail. Yeah, I will actually test this little one, and see exactly if it's doing exactly the same thing as this one. Let me actually change the capacitor, because this is an electrolytic there. Maybe that's because it's that electrolytic, maybe that's the problem, but I highly doubt it. So here is a fixed capacitor of and I don't have one. I need 1 microfarad. Yeah, exactly. You see, 1 microfarad here. 400 volts is this one, and this is for testing only. With this occasion, I will test the actual component that I will use here. SMD 1 microfarad. You see, 1 micro there, and I will take this out, and I will test exactly that in the chill quit here, right? Let me add some legs to it and mount it there and see the results. And voila, here it is. I soldered 2 pins to it, very simple. And I didn't test it yet. Let's see how it's performing. Yeah, it's doing the same problem. Yeah, it's running by itself at the speed that he wants. Okay, so if I'm removing there it is, the link. All right, it's exactly the same operation like before, like with the electrolytic. I was thinking maybe the electrolytic capacitor is influencing this guy here, is influencing the kickback effect that I'm thinking that is happening, but it's really that it doesn't matter the capacitor that is used. So right now I'm using a fixed one and is doing the exact same error and result. Yeah, no, it's okay. It's okay. I'm happy that is working actually. And yeah, okay, that's it for this experiment. I actually specify it here, 7414 with no ground or pin 7 connected. So that's important for this thing to work. So I played around with this buzzer and it's very large. So I am planning, my idea is to put this cardboard, but as you can see, this cardboard that I'm having already installed or glued here is having a little bit of outside zone. So this will solve actually that problem as well. If I'm gluing this to this and degluing this, taking it out and regulate it here, it will actually have the entire surface of this element glued to this. But in the process, I hope I will not destroy the quite fragile cardboard element that is here surface. We'll see after I will do it. All right, and this is it. This is it was quite strongly glued here. As you can see, it got out the paint from this other cardboard that was glued to. So this is how I'm prototyping. If I don't like something, I deglue it and reposition and reassemble it. It's really not a big deal, and it's not costing me anything, only time and patience, and to be careful. Right, and after a little bit of repairment, because I had to repair a little bit that little fucker there, that pin from this, specifically from this potentiometer that is always giving me some freezing errors. I also messed up this wire, I put it there, and then I realized, hope I have to drag it only until here. So I had to take out this entire switch out, and the wire is at the limits right now. It's having like this on both sides, linked to the pads like this, and now it's working as it should be. Yeah. Fucking hell. And to my embarrassment, I messed up one wire. This wire that is going to the clock, I put it on other pad, and it should have been in the middle, in the same line with this resistor and the LED. So the LED is literally on the clock. Yeah. So here, the LED is literally on the clock pin here. So I put this wire here where this was clocking, and I was getting the effect. You see, when I was switching to single mode, I was getting continuous running there, and I shoot myself a little bit because I thought, well, it's another new problem. But then I cooled down my head and I said, well, maybe I actually look back in a couple of movies and I couldn't see anything, and I was checking actually this connection here, if it's correct or not, because this one I put it there in the first place. That was the first error, and the second error that I made, I put this wire here on this pad instead of that in the middle. Yeah. Shit happens. So even to the best of us, especially to me. And yeah, the idea of putting this larger cardboard here is to enlarge the space and to make space for this buzzer to stay there in the middle. And I know it's black on black, it's a little bit shitty, but I will have a lot of space there. And then for this other switch here, and they will be properly aligned. And this is actually how I'm designing things. I'm placing them exactly as you are seeing right now, and I'm thinking what I need, what I don't need, you know. And yeah, you see, here I'm having a little bit of extra space outside, so this one I will probably put it there. Now I have too much space. Yeah, I didn't cut the cardboard. I said, well, I will cut it after. I'll make it. So now this should be somewhere there, and this should be here. I have a bit more extra space, but it's looking like a rocket right now. This is how it will look. So now I can play with this very large buzzer, which I don't like its size for this particular project that I'm having here. I really wish I didn't burn this one. This was perfect. This was absolutely perfect. Well, again, shit happens. And I will actually, with this occasion, I will probably look on the internet and see if I can find small buzzers. Not exactly like this one, but small enough. especially for this kind of projects that I'm having here, and also to be active buzzers, not passive buzzers, because it's a big difference. And I took the kick in the balls with the passive buzzers that I'm never using them. I will probably make some circuits in the future with some passive buzzers, but only for experimentation probably. But for general use, be aware to have active buzzers in your arsenal, because it's easy to use, very practical, very practical to use them. Plug them at 5 watts and they work. No shit about it. No, that's it for this part. Now it's repaired. Outside of the scope of this video, I changed back my original very thin wire. This is actually an audio wire, if I'm not mistaken. So before I was using this very stiff cable that is staying only in one place, and I have to put my circuits around this stiffness of this cable. Why? Because I was having only one pair of plugs like this. This is called, actually it's having a standard name. It's called banana plug. So this banana plug is a standard name. So there it is. There is connected. And because I had only this banana plugs here that came with this device, I changed the original wires that it came with. I don't even remember if it came with wires. I believe it came only with the banana plugs and that's it. And I had to find a wire to connect to them. And I use it quite sometimes this very long and thick cable and stiff, and now I'm back to my original very thin enough wire that is very malleable. I'm really used to work with it, especially for small not power hungry circuits that I'm having here. And also this is a secondary, so I'm having two power cables right now. And it crossed my mind at some point while I was fighting with the stiffness of that other wire to search for some plugs on internet and on AliExpress specifically, and because eBay is very expensive right now. It was the cheapest in the world, eBay, but now is a bit more expensive than AliExpress. And I commanded these plugs. Well, I commanded 10 of each. These are the pairs with the female, and this is the male. If I want to build something, I have this 10 and 10. I believe 5 red and 5 black, something like that. It's not 10 red. Yeah, you can actually see 1, 2, 3. Let's change 5 of each color, and in total I have 10 of each color, but not anymore because I use them here, and they fit exactly perfectly here. In this is 4mm, I believe it was there. I believe it's 4mm, like that. And it's fitting absolutely perfect. It's not exactly the same design as the original one that I had, but is good enough. Is more than good enough. So I'm very happy with this. And it's good to have different cables thickness, because this will conform with the circuit. It will not drag it around. It's very malleable. And I really get used to using this cable. And that's the story of the banana plugs. So I changed my mind again, and I cut this cardboard because. And I remounted. I took it out, this button, from that longer cardboard that it was before, and I remounted here. And this cardboard is like a piece of material right now. It's very wibbly. I glue it. It's staying put, but when I had it before, when it was unglued again, it was like a piece of rag, literally like that. And this is where I thought it's probably a better place for this buzzer to have it here on the back. Because I have a ton of space here actually, and is also this chip is occupying some height, so this buzzer is another chip pretty much here as the height, and probably here I will put a distancer to equalize these two. So that's how it's looking right now. It was a genius idea to put it on the back here. You can, and it's not mounted to anything. That is the border of the cardboard. That is not a link of anything. And this one as well is the border of the cardboard. It's not a link, and I didn't link it to anything. I also marked with red and blue the polarity, because this is polarized. It needs positive and negative specifically. If you switch, it will not work, or worse, it will be destroyed if you switch the polarity. I don't want to see if it's getting destroyed, so I clearly mark it there. And now I liberated a ton of space here on the front, and it will be a little bit more higher, but yeah, I can deal with it as being a little bit higher. It's like a little box. It will have a nice box on it. I like it because it's very small, you know, and it's doing a lot of stuff. Everything that you are seeing, this entire project, probably I'm repeating myself, but is made around these two chips actually. Well, let's say around 4070, around this chip. This is the brain, and actually 7414 helped a ton with gluing the circuit to actually make it work as I wanted. Well, the astable one, but the positive edge detector circuit, and also the buzzer, but I didn't need it to be Schmidt trigger, not gate for the buzzer here, I think. I'm not completely sure. Maybe I'm wrong, but it was a glue chip that linked everything together to actually function properly. Very cool idea, very cool subject, very cool project. I really like it, and it's not that I'm learning something new. Actually, I did this almost without only from my brain alone, from my knowledge alone. So I was. And as you can see, I'm building it step by step, and I'm adding to it. Although I made the interface, I drew an interface sketch on my computer there, and I was thinking beforehand, yeah, I need that module, that module, that module, that module, but I didn't actually draw the circuit. Right now, when I'm building this thing and I'm testing it, right now I'm actually building the circuit modules. Each module of, that is connected to the entire ensemble that I'm having there. I modified also, I corrected the final circuit here. I raised that LED that remained there, linked to the positive, and I link it exactly as I'm having it here with 10 kilo resistor, and the LED to the ground is exactly as I'm having it there. This is the LED, the signal LED, and it's on this clock line to the pin 14 for the 4017. And from this, exactly from this line, I'm dragging the wire, and I'm powering the buzzer there. 5 volts active buzzer, and 7414 pin 7, no ground for the chip. And here are the values: 1 micro, 100k for this resistor, and that's it pretty much. Yeah, I didn't expect to use that much of this 7414 actually to be that helpful. I really didn't. And now when I'm actually using it, it's an eye-opener. Practice is the best teacher. I know it from a very young age actually. All right, mission accomplished. I managed to make it. Right now is a little bit random. As you can see, the beeping is not at the same interval. Is it's like a Morse. It's because let me shut it off. It's because is behaving exactly like that circuit that I'm having there, and I actually link it to the ground. I link it to the ground because without linking it to the ground, it didn't work. Sometimes it was working, sometimes it didn't work. So even if it's having a little bit of error or randomness in the sound, it's beeping all the time. That's the idea, you know. But that randomness is only when the sound is on. When the sound is off, is running correctly. So you see, yeah, and it's extremely loud. It's extremely loud. Let me actually show you the circuit. Holy fucking shit! It was quite hard to actually implement it on what I'm having here. I put this seal. Here, this is the original seal actually, because it's way too loud, and this is estompating a little bit the sound. But this is the board here, and I'm having. I know there are a lot of wires. There is the capacitor that is getting the signal from this wire here. There is a resistor somewhere there that is going to the ground. I know it's very hard to. Let me actually hold it in my hand. And it is a tiny resistor that is getting its 0 volts from somewhere from there. Actually, like I said, I linked the negative pin to the ground of the chip, and I'm not completely sure why is random like that. I'm suspecting maybe it's the other inputs that I have to ground them as well. Who knows? But so far I have to take out quite a lot of wires from here to make space and be able to get with my soldering iron inside there, and it's a pain. It was quite hard to actually get in there. So theoretically it's finished. All that it needs is a case, and I will work on that later. What I didn't like, it was full of errors until I reach it to this stage that you are seeing it right now. And it's still buggy a little bit, but I really don't mind because I work so hard. So a tiny little bit of bug. It's yeah, it's fucking loud. And this randomness is quite hilarious. Actually, I'm laughing on it. It's like Morse. It's very random, which is nice in a sense. You see? But if I'm interrupting it, is moving correctly, is cycling correctly. Only the buzzing is creating some inconvenience. And of course, if I'm rotating the speed, is probably you want to hear it. Okay, sorry for the loud. It's very loud. It's extremely loud. And also this mode here when I'm pressing the button, and also the reset. Of course, it's not staying correctly right now, and you see, very cool. And here is automatic. Belle. Okay. Yeah, but I like its dimension. It's very, very small and it's doing the job. And it's also funny. It's a funny circuit. Right, I will have to make a case for it and it will be done. This is a circuit that is made around 4017 chip integrated circuit. So everything you are seeing here, that's the idea. This is the idea to make something around that chip. And it's quite complex. It got quite very complex very quickly, actually. Good news, I believe I find the solution for the erratic beeping, for the random beeping that is creating. I did a ton of tests actually until to get to this very simple result that I'm having right now. I had to erase here this section and to insert a diode 4148. You can see it here actually, and I took out the signal to the beeper from inside this entire circuit, so it's out, and I put this green wire back, and I connected it to the test board here. If I'm rotating now, you see it's actually working and corresponding. Doesn't matter if it's connected or not, it's working the same, exactly the same. It's not changing. And if I'm like that, see, it's the speed is not changing. I know the camera might interfere. Yeah, see, it is with the beeper and here is without the beeper, and it's not skipping steps. So this is without and this is with. So before I was having this random skipping steps, and also when I was increasing the speed, it was not actually beeping correspondingly. The LEDs here were going nuts as well, so I was getting some clear indications when it was working very bad, you know, when it was not working correctly. So I broke the problem down to the buzzer itself. The buzzer is the problem. When I'm removing the buzzer from the circuit, everything works absolutely perfectly, but when I'm inserting it in the circuit, somehow is affecting the 7414. And this time I actually linked everything correctly. I linked every input of this chip to the ground, and I also added its negative pin to the ground as well, not as before. So it's working absolutely fine. But with this specific diode here, exactly after the last output here, I actually tried it with the transistor there, with this Schottky diode, which is faster and lower voltage than this one. Also with the LED, actually with the LED worked also good enough. But I was having problems because I was actually using my scope probes here in the circuit. Specifically, I leave the scopes here exactly where the input is, and somehow it messed up the finding of the right component. This diode didn't work while the scope was there connected, but after I took it out, but it worked with the scope connected with the transistor. So I removed the scope and it was still unchanged with the transistor, so then I changed back to the diode and it worked. Somehow the scope was interfering with the result, but now it's working absolutely fine with this diode. That's the remedy. Probably it will be easy to mount a diode on the positive pin there of this device underneath here. Yeah, it might be a very easy fix with all the circuit built in already, so hopefully it will not be a big problem. All right, that's it. The experimentation is successful and I remedied the problem. As you can see, it's not jumping, it's not making that Morse code anymore. All right, I want to mention that this is another beeper, brand new beeper, and the beeper that I'm having there, I didn't take it out to put it here. So that's why it's very good to have multiple components and to be able to test with them, a series of components. That's important. I put this SS24 Schottky diode. This is how they are looking, if you didn't know. And I inserted it here in this circuit. There it is. It's standing vertically. You see it here, where my finger is. And yeah, it's connected there and it's doing the correct business now. It's not doing that Morse code or erroneous beeping. I also tested it already. Yeah, it's very, very, very responsive, as it should be. Yeah, now it's normal. Now it's working correctly. You have no idea how many times I repaired this shit, and now I had to find a solution to this little shit problem. But I'm very happy that it worked, and with a very simple, extremely simple solution with a single diode. So you cut a little bit of power from the buzzer pretty much using this type of diode. But that SS24 diode that I use, SMD version, that is 0.2 or 0.3 volts over it, so it's not consuming too much from the buzzer. So now is actually buzzing. The sound is coming from here, from this buzzer. By the way, when I'm switching the sound on and off, is no change in speed or timing. You know, is exactly the same as it should be. I was thinking on this kind of distancers to add there, and then after I'm adding those distancers made from whatever, from a tiny little block of wood or some cardboards pressed one over the other, and then after that to make the actual box of this entire circuit. All right, here is an update. As you can see, it is standing alone by itself, and if I'm pressing here on the buttons, is solid because I made this distancer made from cardboards. Here are my cardboards that I took them out, and here is the glue. It says here Lipige de Timbre. It means very mild, very watery glue. Very shitty for everything else, but for paper and also cardboards is excellent. Is doing a great job. It's dedicated for paper only, and it's not a general purpose. This is general purpose. I can glue your mother with it. It's very good actually. It's extremely good. This is for shoes. It's having there a shoe in the drawing, and this is how it's looking underneath from pieces of cardboard stuck together to make a distancer, and to conform to what wiring I'm having there, and is stepping on all of those wires, and is actually a tiny little bit, if you can see, higher than the buzzer, a tiny little bit, because this all these cardboards here, as you can clearly see, they are compressing a tiny little bit. So when I'm pressing with time, they will get flat the same level with the buzzer, that height that I'm having there. And here, if I'm pressing here, you see, is good. Here, if I'm pressing, is very good. Here in the middle, I'm very interested to stay put, to not move at all when I'm rotating this. You know, you see, it's very stable. And here, and it is in limits. This distancer that I made here from cardboards, exactly in the limits, in the with it, and it's very good. I don't need a distancer here for this display. I really don't need it. I can make one, but it really doesn't matter. And next, the box, the actual box. Well, I'm thinking on a preliminary box and then another box around this box, this preliminary box. A more funky design, a secondary box that is more pleasant, with more design features, more interesting looking is what I'm after. But I hope I can do it. I really hope I can do it. If not, I will leave it with only one box and that's it. You know, one single, the first box, preliminary box, and that's it. But I am considering to actually to make a secondary box with more design features, to look more pleasant. Pretty much it's only for looks, to look good, to look interesting, to look funky, extra mega funky, to look very good. Actually, that's the purpose of the second box. The first box, the preliminary box, will be to it will have a functional role to actually contain everything and to protect everything, you know. And all right, this is it. I put it in a case. It's a very adaptable case. Let me show you some sketches. These are actually the sketches for the box, and these are paper prototypes. And then I built the actual final cardboard box, and it's functioning fine. I had a single interruption on a switch here, but because I was pressing and manipulating everything. But other than that, everything went pretty cool. So let me summarize it for you. This is that sketch. This sketch here is this sketch. Well, prototype paper, and this one is the box. This is the box all around. So I'm having these three elements. So now I will take it out for you to see it. Actually, I push it down inside this box. It's quite a press fit here, but I think I can do it. I can take it out. I should be able to take it out relatively easily. Yeah, something like that. I should make an ear. So this is let me do it like this. So this side here, I didn't, so this is how it's coming off. Yep, like that, you see? There's a piece of cardboard, is that. So this is this. This is the distancer. And here is a little bit of, is this case here. And it's quite cute, I like it. And here is the box. And that's it. And let me reinstall it back again, how it was. It's very simple, like that. I have to put this distancer here, which is very good actually. It turned out to be very good. I have to hold it there. I stopped the beeping. Everything is beeping correctly, no problem. But I stopped it because it's quite annoying, especially now when I'm putting everything back like that. Okay. And now this is the hardest part actually. When I have to press fit it here. At least it was the hardest part when it was new, brand new. But now it probably made a little bit of room already. And it's, yeah, like that. Excellent. Good enough. It's not perfect, of course, but it's good enough for me. And that's it. Voila. This is my very strange casing. But it is protected quite well from falling, from exterior elements, pieces of metal, etc. You know. And it's quite safe if you don't wet it. Let me bring the beeper back again, and this is how is beeping very fast. Excellent. Okay, this is no beeping at all. Well, this is stopping. This is for manual, and this is the manual. I say it's excellent. And here is the reset. And reset, reset. Fucking excellent. Fucking excellent. It's not perfect. The casing is staying like this. The casing a little bit. These two parts. Yeah, but it's good. The only thing I have to add is an exterior wire, and I'm thinking this signal to take it out to drive something else probably. So it will be probably a fourth wire. So 4 wires, 2 for powering and 1 for external clocking, and 1 for to receive external clocking and to count it. That's my idea, but I will see what I will do in the future. So far, as a device in itself, and the size of it is quite good. I didn't expect it to look so good. It is looking good, I may add. By the way, if you were wondering what this cardboard, beautiful cardboard I have it from, is from antibiotics, from amoxicillin. Amoxicillin is antibiotics that I have to take when the seasons are changing. I'm very sensitive, susceptible to bacterial infections. That's it for this project. I believe I must put an end to it because it took me like probably 1 week or 1 week and something, and a couple of days, so probably around 10 days to build the entire project. The chill quit, the testing, the errors, to solve them, and little by little, day by day, I stay over it, and look how cute it is. So it's a kind of 50-50, but 50% SMDs, 50% through hole. But yeah, I am happy. I don't think it could be miniaturized more than it is, like it is here. Probably it can be miniaturized, probably a bit more thinner than this thicker, especially if I'm having a thinner beeper, because all this thickness that I'm having here is specifically for the beeper height. Another thing, I will have to add some text, what all this stuff means. And probably the circuit diagram I will have to remake it, because here is just a sketch. But I will have to remake it on my PC, on my computer, and to look a bit more nicer and more clear. And ideally, to actually fold it and put it inside this device to have it on hand when something will go wrong with it. Probably it shouldn't, but who knows? You know, it's good to have the circuit inside it as a circuit diagram. Right. Back to the problem. As you can see, the LED is jumping 2 by 2 or whatever. Sometimes it's working normally, sometimes it's jumping. Fine. I was trying to add this signal wire here, and I observed this again, this random behavior, and this time it's having that diode. It is having it and is not doing anything. And I took out the wire and it's still doing some random. It's the same behavior like it is right now. I have no idea what is the actual cause that is doing this thing. In the tests here, so pretty much to summarize it, sometimes it's working okay, sometimes it's not working okay. So that's the problem. That's a very big problem actually. And the tests that I did here with this circuit before, exactly the same behavior I had either by using this 4148 diode, a Schottky diode, and then I tried with a transistor like I'm trying it right now. And with the transistor, it did give me excellent results without any jumping, without any problems. So right now I will put back, I will connect this wire here. And yeah, it got nuts a little bit, I don't know why, but it is functioning absolutely fine, correctly, without jumping. This is the problem. When it's connected to the base of the transistor, it's beeping as long as this signal is activated. But by using the other way, it's doing the correct thing. This is not the correct thing that it's doing right now. That's the issue. That's why it's weird. It's a bit weird circuit. So I had to, let me put it back. So as you can see, the signal wire is going to this 10 kilo resistor, which is going to the base, is receiving the positive rail through the collector, and through the emitter is going through this buzzer here. So that's the problem. Okay, so I disconnected the circuit that was inside because the previous circuit that I tested here, it was beeping as long as this LED was lit on. That's the problem. But now the test circuit with the transistor, with the base connected to the positive rail all the time, and only the signal coming to the collector and to the emitter is going through this beeper, which is, you can hear it right now. This is the beeper that is running, and you can see it is not staying as long as the LED is lit or on. the beep. The beep is very short, tuck, all the time. And when I will increase the speed, it will not fuck it up. Probably I'm touching something there. So as you can see, it's still running correctly, even at high speed. That's the idea, to get a very short pulse, a very short beep, indifferent of how long this LED is staying lit on. And the other circuit, the test circuit that I made here, probably the internal circuit that I'm having here was all connected. How it was connected here, it was interfering, and I didn't get a good result exactly in this configuration, and this, like it is right now. The case when I'm using a diode, and it looks like it's working fine. You see, it's working fine. Sometimes it's working, sometimes it's not working fine. That's the problem. Now it's working absolutely correctly, and you may think, wow, it's pretty good. I'm not even sure with the transistor. Maybe it'll bring up some new problems, some new errors. I hope not. But it's interesting. It's interesting. I was expecting to have an issue with the diode, but previous tests, it gave me an error. This time it didn't. It doesn't give me any error. I don't know why. Okay, I changed this diode here. I changed it with 4148, exactly as I written it here. Let me actually show it. There it is. Where it is? Here. Here it is. This 4148, and let's hope it will not be a problem. It worked for a very long time actually with this diode correctly, until I started to mess around here, and I added this wire for some reason. Probably it was a temporary error, and it's actually working with that diode. But I don't want to add a transistor. I actually prepare a SMD transistor there, but it's a bit too much work, and I have to fit it there, and now I don't want it. It's easier with the diode. It's very easy with making it with the diode. So now, pretty much what I'm having. So this is the idea, is to add a new wire. Like I said, I had a ton of errors with this circuit, so it's doing the correct thing right now. And also on the fast here is not jumping at all. It's actually running as it's displaying there. And now it's jumping. Oh, I think I know why. It's jumping. Is this motherfucker potentiometer? Motherfucker. Yeah. When I'm changing the potentiometer, is running weird. Damn. I have to change it with a brand new one probably. So I finally changed this potentiometer with a brand new one. I have no idea how it's working right now. It should not give me any problems. But if it's doing it, yeah, this is the preliminary. This is how it's starting actually. This is not a problem, but it's beeping correctly. Okay. So when I'm rotating from here, it's slow. Okay. It's not jumping. Yeah. Okay. So this is a brand new potentiometer. I said that it will work with this potentiometer that was brand new, but I managed to fuck it up. And I thought I can push the circuit longer with this fucked up potentiometer, but I should have changed it way more earlier than in the last minute right now. If that potentiometer was the actual cause of jumping around, then because like I said, sometimes it was working, sometimes it was not working with the diode. So it doesn't matter what diode I'm putting there, it's still working with the diode, which is a great news actually. And I'm very happy that probably right now at this point I solved the problem of jumping, the error of jumping. And all this trouble was for me to link this wire here, this very faint wire you are seeing here, that is going directly to the clock actually. So that's how I link it, this yellow wire that you are seeing here. And let me actually show you. Right now, theoretically, I should receive the clock through this wire. All right. So let's see with my testing LED here. Excellent, exactly like there. So right now, I'm collecting the signal through this yellow wire. I can put it inverse. So now it was positive here and negative here, this LED. Now I will put the positive here and the negative here. You see, it's the inverse of the green. But the point is, I'm receiving, I can collect the signal through this wire, and I can drive, I can clock with this yellow wire, I can clock something else, something from a circuit, you know, and as fast as I want it. But usually I want it slow enough to see what the fuck is happening, you know. So that's the output. This is the output. It right now is in the output mode. But now I will make it as an input, the same wire. That's a very interesting idea, to link this wire here on the main clock line. So now when I'm switching to manual, when I'm actually pressing this button, I'm transforming this wire from output into input. So now I'm not getting anything from it, but I can transmit through it. Let's see. And when I'm connecting it to positive, the negative is not working, but only the positive signal. But the idea is that I can collect the clock from a circuit, and I can visualize it here while it's moving. You know, this will be an emitter of signal and a receiver of signal, pretty much, and displaying the signal. That's the idea. So that's now at this stage it is completed with this third wire that I had quite trouble, trouble. With this exercise that I did just right now, I showed how you can use it, how I will use it, if I will use it like this. I don't like it, this distancer, but it is practical after. I don't like it when I'm assembling it like this. Is going. I have to hold it with my hands all the time. Oh shit! Because I changed the. It's a problem. Yeah, because it's a cardboard, it's malleable, and I can. Yeah, probably I can do it like that. Yeah, it's very shitty way of here at this stage, but it will hold fine while it is inside. So this is the idea. This is the idea. You can use this as an output and as an input. Yeah, like that. Pretty cool. Pretty cool. Or inverse, like that. Yeah. Yeah. Okay. And also as an input. Let's see. Now it's jumping because my contacts are jumpy. I may say it's quite precise with the jumping that I'm having here. And basically for testing. But the most important thing why I built it because I wanted this round display, which I find it very cool, very interesting idea. And it is my original idea. I didn't see it anywhere. This project ate me a ton of time, especially with the problems that I had with it. And the most problems come from this bad potentiometer, this one that I changed it already. Well, I never learn to change immediately. When I catch the motherfucker that is bad, to change it immediately and to throw it away. Sometimes I'm still using the bad components in the hope they will work, and they are deceivingly they are working. But when the world is the best for you, they stop working, and they fucked up your day. A couple of good hours of debugging and figure it out what is the problem, and it's usually that component that you left it because you thought, yeah, maybe it'll work. Maybe it'll work. So it's a very bad mentality that I have personally. I should change it. I already changed it right now, but it was a little bit too late because I had a ton of errors and I couldn't figure out which was the actual cause. I was thinking one or another, but it turned out that motherfucker was the problem. Who knows? Maybe it's even working without this diode. But this diode actually fortified a little bit that signal, strengthened it, not to be too weak. So this is the clean circuit, not as messy as on the paper. It's good to have it here in the clean to actually see every value and what everything means and how it's connected. When I run it, let me switch it from the button for the moment right now. It's working fine. But if I'm switching to this auto oscillation, auto clocking element, it doesn't work here in the simulator. So I have to link an oscillator from the program to actually clock it automatically at 10 Hertz. As you can see, this is at 10 Hertz. So I'm bypassing a little bit this just to show you that it's working fine. At least the display here and the pulse signal here. I'm not sure about the buzzer because it doesn't emit any sound. So that's, let me undo back. So that's the idea of this circuit. It is working here in the simulator, but I have to help it a little bit with that clock there. But the idea here is for this circuit is to show a very clean diagram, basically. So let me show you the reset because that's working also. Let me pulse it from 1 to 1, and now the reset here is jumping there. So it's doing excellent. So I really, this is the output wire, that yellow wire that I had there in my circuit. Of course, positive and negative wires, and here to 5 volts. And it's exactly as I made it on my paper, exactly. And what I didn't make on my paper, and I didn't mention it there, I totally forgot, is this enable pin that is going directly to the ground. And I modified on my sketch, but it was too late. I already finished everything. But for the record, this pin 13 was always, all the time, linked to the ground, even though in my diagram there on my paper it's not showing at all. Okay, All right, that's it. Oh yeah, oh yeah. It's very nice. It's very nice. All right, thank you very much for watching. And goodbye from your favorite artist electronist, Mr. Q12.